Once we know about isotopes, we know that a sample of any given element will have atoms of different masses. So what we're going to calculate next is the average mass, which is called the atomic mass. And you can calculate an average the same way you already know how to calculate an average. Let's say you were given these quiz scores. The average would be the sum of all your scores divided by the number of quizzes that you took. So if you add up all these scores, you should get a total of 25, and there were 8 quizzes, so the average is 3.125. Now notice, how many times did this person actually get a quiz score of 3.125? If these are the scores this person earned, that was never a quiz score. The average does not have to be one of the numbers that you put in as the possibility. So mathematically, if you took 6 million quizzes, you could calculate the average the same way. You could sum up all 6 million quizzes, divide by 6 million, and that's going to give you the average. That's what we have to deal with when we're measuring atoms, because a small sample is going to have millions and millions of atoms. So if we were measuring the mass of those millions of atoms, it would take forever to calculate the average using this formula. So an alternative way to calculate the average is you take the sum of all of the fractional chances and then multiply that by whatever the value is. So again, it's a lot easier to see when we go back to the quiz example. Taking 8 quizzes, what are the odds that the next quiz will be a score of, let's say, a 1? Well, if the first 8 scores predict what you're going to get on the 9th score, how many times did you actually get a 1? You got a score of 1 twice. So the fractional chance is 2 times out of 8 you'll get a score or a value of 1. And we're going to sum together all of those possibilities. How many times did you get a 2? You never got a 2, so we don't have to worry about that one. The odds of getting a score of 3, we had 3 quizzes that out of 8 that got a score of 3. And continue the same way. A score of 4, 1 time out of 8 quizzes you got a score of 4. And then score of 5, 2 times out of 8 did you get a score of 5. So if you add together all of these, multiplication, sum them all together, you're going to get an answer of 3.125. Right? Mathematically, it's the same thing as what you already know about how to take an average. It's much more useful instead of dealing with 8 quizzes, like I said, if you're dealing with 6 million quizzes. We switch this to chemistry, and we're going to calculate the average mass of an element, such as silicon, which has 3 isotopes. We call the isotopes number 1, number 2, and number 3. Someone weighs isotope number 1, and they come up with this number, 27.9769. And an atom is really, really small, so instead of using grams, we use a small unit, which is called an atomic mass unit, AMU. It turns out of all the silicon in the world, 92.21% is that version, that isotope of silicon. So 92.21%, if we want to change that to a fraction, that's 92.21 chances out of 100. If you randomly select an atom of silicon, it will be isotope number 1. Same thing for isotope number 2, but notice the percent is lower and percent 3 is also lower. All these percentages have to add up to 100%, just like your score on an exam. The score correct plus the score incorrect has to add up to a total of 100%. So we can use this to find the average, which is the atomic mass. By using that same formula, we're going to sum together the fractional chance of picking one of these isotopes. So isotope number 1 has a fractional chance of 92.21 out of 100, and the value is the mass, 27.9769 atomic mass units. And we're going to do that for the other two isotopes. 4.69 out of 100. That's the odds of selecting isotope number 2, which has this mass. And isotope number 3, 3.10 out of 100, and its mass Now, in a problem like this one, we're not worried about sig figs. If you multiply all this through, add it all together, you'll get a value on your calculator of 28.09. And if you notice on the periodic table, you have the element silicon. There's a 14 above it. That's the atomic number Z. That's the number of protons. And then underneath it, you have the number 28.09. And this is something we're going to use a lot during the rest of this class. That number underneath the symbol on the periodic table is the atomic mass.